0.
So let's plug in 0 and 0. That should be pretty straightforward. X minus 0 squared plus 0 is going to boil down to a very simple ax squared. Is there any point that we can plug in for x and y? Any point that's on our graph?
6.
Fine, plug them in. Find a. How much is a?
118.
Right. So if you have 1/18, that's your stretch factor. It tells you that the opening is rather shallow, which makes sense. If you're going 12 across and only 2 up the entire time, then a stretch factor of 1/18 tells you it's a very shallow opening. That the a value is positive tells you the parabola opens up. All right, that's all stuff we know already. But let's move on to what we talked about yesterday with the focus and directrix. There's a little bit of a connection between the focus and what was our focus? What was the general gist of it? Remember our definition of a parabola that used focus and directrix? What was that? Somebody besides Mackenzie, you've been great, but let's involve some more. Good, Shay?
Well, the definition of a parabola.
Go ahead.
The set of points on a plane equidistant from a point called the focus and a line called the directrix.
All right, so we're going to, let me get this guy out of the way for a circle and make a little bit of room here. Yesterday we were doing a line drawing activity where you had the parabola. We had a point, a fixed point that was called F for focus, and a line that we found called the directrix. And right now these don't have any meaning at all. Then we started finding points that were the same distance away. And one that was very easy is if you drop straight down, halfway in between, we had a point that was equidistant from the focus and the directrix. We called that V for vertex. And then we found other points. So if you went out, say to here, and said measure that distance and measure this distance straight down at a right angle, so we measured off equal distances, we found another point that was equidistant from a focus and a directrix. We found matching points on the other side. We found several more points, right? So that if you went out here and straight down, if these two segments were equal, this would be another point that fit our condition of being equidistant. So that's just a recap of what we did yesterday. Then if we did a smooth curve, connect the dots, once we had several points, we had a shape that was a parabola. All right, so now where we're going today is to make a connection between the formula we have and the shape, and what about focus and directrix. This measurement from the focus to the vertex was just any old number, we'll call it C. It was a certain measure away, and from the vertex to the directrix was the same C units away. All right, so you would go add on C to go up from the vertex, subtract C from the vertex coordinates to get down to the directrix. Is everybody all right so far? All right, so now if we took any point at all, I'll call this XY. We're going to take any point at all and find the distance to the focus. We're going to put our little grid up here. Oops. Kind of go through the, okay, pretend that goes through the origin right there. I've almost got it. So if our vertex is at 0, 0, and our focus would have what ordered pair? Very good. 0C. So if we want the distance from the point to the focus, then we have our distance formula as that big square root of subtract the x's squared and subtract the y's squared, the y minus c. How are we doing so far? All right? That's one distance. It had to be the same distance down to the directrix. So if I had another point here, what would the ordered pairs be going straight down from that point? What would the x-coordinate be down here? X, right, the same as the one right above it. And what would the c-coordinate, the y-coordinate, how far down are you? Negative c, very good. So we have x, negative c as the ordered pair. Find the distance, take a minute, find the distance between point P, x, y and x, negative c. Excellent. So Tessa, your distance formula, take us through it.
Well, distance equals the square root of x minus x squared.
All right, subtract your two x's, and what did you get for that part?
0 squared.
Pretty much. All right, so we have 0 plus how much?
Negative c minus y.
It's the same as if you said the y minus negative c, either way. So what is y minus negative c?
Y plus c.
Good. So you've got the square root of y plus c squared. How's that so far? All right. Now the two distances are equal to each other. Right? That's what equidistant means. The distance from one set of points, the distance to the other set of points have to equal. Let's put an equal sign between these two quantities. Can we square both sides and get rid of our radicals? All right, so let's finish that. And take a minute and FOIL these out. We just have a little bit of algebra left to do here. We've got the x squared. What do you get, Tessa, when you square the y plus c?
You get y squared plus 2cy plus c squared.
What about on the other side?
Y squared minus
2cy? Right.
Yeah, sorry. Plus c. Plus c squared.
Right. Good. Okay, what simplifies, folks?
You can cancel the y squared.
Sure, we can cancel out the y squares. Anything else?
C squared.
Great. Like terms together?
4cy.
All right. And get y by itself. What have you got?
You got x squared over 4c.
All right. I'm going to separate those out, the variable from the constant, and have 1 over 4c times the x squared. Is that all right? All right. Let's recap before we go to the next step. All right, a little bit of what just happened here. If we put the lens that we're talking about on a grid, center it along the origin so we can take advantage of the zeros and the balance in the numbers, making our algebra easier. Then we found the focus to just be c units up from the vertex, the directrix to be c units down from the vertex. Again, we're taking advantage of our zeros to make our math easy. Then from any point on the parabola, any point xy, the distance from the point to the focus and the point to the directrix is supposed to be the same. We found both distances, put an equal sign between them, and something shaking loose here. All right? If we put this in the same format that we have our vertex form of a parabola, then our coefficient of x squared, we've been calling it a. And all of a sudden we have a new equation that says, but I've got 1 over 4c. All right? So by matching up our two equations, we have that a, the stretch factor of a parabola, has something very specific to do with c, how far up from the vertex we have our focus. All right? So we've got that a is 1 over 4c. And that determines, before 2 minutes ago, we just thought a is the stretch factor. It's how wide or how shallow, how steep is the parabola. But now we can nail it down tight and say exactly where is the focus located. We can find out exactly where it's located. All right, so if this lens was parabolic instead of spherical, all right, what can we do to find the focus? Can we find the focus now? All right. So what would we do? We've got that a is 1 over 4c. What have we got in our parabola? We had a is 1 over 18. Right? That's what we found so far. A is 1 over 18. And that happens to be 1 over 4c. So how much is c? Take a quick minute. How much?
4.5.
Yes. 4.5, 4.5. So where would that put the focus of the parabola?
0, 4.5.
0, 4.5. Now that's really, really different from the circle. The circle had a center at 0, 10. If we use a parabola, that's got like something down here. It's just, you know, maybe right about there it looks like. I'm just guessing visually. But that would be, well, if that whole thing is 2. So this is not drawn to scale, but that would put the focus at 0, 4.5. So that's really different. They're really far off from each other. And so the question is, which equation models the curvature to produce clear images? So let's put this equation, where did we go? We didn't get it yet. Let's put this information on our graphing calculators and look at both. So if we were at this point that y is equal to a times x squared, we've just found a to be, we had 1 over 18.